All right, so in section 8.5, we're talking about kind of analyzing graphs. Wow, that's spelled wrong. I don't know how to spell analog. Graphs. How about that? Okay, so if we want to talk about graphs, we need some definitions to kind of play along. So
Analyze.
I know, but I don't know how to spell it, so I took it out.
You spelled it right. It needed a Z.
Yeah, the S.
Yeah.
Z.
Oh.
Okay, envision the rest of the word around the Z. Does it really matter? Graphs, right? Okay, so we need definitions. The definitions we need are a function is called is increasing. So increasing is the word I'm defining here. If its graph rises from left to right. Okay? Does that make sense? Really what I mean is the graph does this kind of a thing, right?
Oh.
Basically it's going up, right?
Like a.
Yeah, as I look from left to right, it goes up. That's what I mean by increasing. This is a pretty arbitrary definition. It has to do with if I increase the input, right? If I increase the input, I get more output, right? Okay, so that's why we call it increasing. So another definition, a function is decreasing. I'm sure this one won't come as a surprise, right? If its graph, oops, not a contraction. If its graph, what? Yeah, I need a word for goes down, right? So lowers, sinks, decreases, falls.
From left to right.
Yeah, I'm trying to define decreasing, so I probably don't want to use decreases, right?
Goes down.
So rises, falls is kind of the opposite word, but there are a number of words that you could put in here, right? From left to right. I don't know why I'm capitalizing left and right. So that looks like something like this. Okay? All right. One more. A function is constant if
it's horizontal.
Yeah, so the options, right, were either it's kind of going up or it's kind of going down or it's not doing either, right? If it's not doing either, it's flat, right? So if it is horizontal, or flat.
A single point is constant.
Ah, yeah, so there gets to be some weirdness when I'm not drawing a kind of a line-shaped thing, right? So if I was drawing something like this as a graph, this isn't much of a function, but yeah, it's a constant function. You see that? Yeah, this is just a point, right? It only has one input and one output. It's sort of stupid, right? This is not a graph we're going to talk about a lot in this class, but yeah, that would fall under constant.
Is a vertical a constant, or is it just going to be undefined?
So is a vertical line a function even? Why not?
It's not horizontal. It's vertical because it has more outputs for one.
Yeah, this is not a function because it fails the vertical line test, right? It has lots of outputs for one input.
What about parabola?
Yeah, so what about a parabola? Okay, so here's examples. This thing's not a function. Not a function. If it's not a function, can I say that it's any of these things? No, because all of these things are about functions, right? So this one, the words don't even make sense. Okay, so this one's kind of, whoops, wrong thing, right? We really don't have a word for this one because it's not the kind of thing we're talking about. Now, if we talk about a parabola, which is another good example, here's a parabola opening upwards, right? Is this increasing, decreasing, or constant? Show of hands for increasing? Show of hands for decreasing? Wow, decreasing is way less popular. This is both. Oh, crazy, right? Yeah, I tricked you. It's increasing over there, right? You guys see that? Above that part, right? It's going up from left to right. So it's increasing over there.
Oh, yeah.
Over here, what is it? Yeah, it's decreasing.
Why is that? Oh, because it's negative. Okay, never mind.
Yeah, because sort of the slope, kind of, right? You have things that weren't lines had slopes, which they kind of do. The slopes on this one would be negative, right? It's going down. The slopes on that one would be positive. Believe it or not, that's a section in calculus. That thing you guys just intuited, the slopes being positive and slopes being negative, that's a whole section in a calculus course. You guys are good at this. I'm excited. Anything else?
But the equation for that would still be positive, right?
So the outputs are positive, right? Does that make sense?
Yeah.
But the outputs don't matter here. All that matters is whether I put in when I put in a bigger x value, does the y value associated go up or down? It doesn't matter what sign they were to start with. You guys see that? So let's draw some more pictures. So maybe here's a picture. Is this increasing, decreasing, or constant? It's both increasing and decreasing. Where is it most obviously increasing? Yeah, this stuff on the right, starting where? Like someplace at the bottom here, right? Where it starts going up. So this is increasing.
And over on the left would be increasing also.
You guys all see that? Till I get to this top, right? As I move from left to right, the thing's going up. So that's also increasing. And then in here, what's going on? Yeah, that's decreasing. Guys all see that?
So if we're doing that and then it levels out a little bit, put a constant in there also?
Sure. So let's make one that's got a spot where it's constant. Okay, so far we've just been labeling pictures, right? We don't often get to label pictures. Usually things are a little more complicated, right? So here's maybe the next step up. So a problem for one of these would say find the intervals of increasing decreasing, or constant. Maybe find the intervals where f of x is increasing, decreasing, or constant. So there's a couple ways to ask this. This might be the easiest one to understand. Okay, so let me give you a picture. Okay, so here's a picture. Okay, so what am I wondering? I should be looking for increasing, decreasing, constant, right? Which of those is going to be easiest to spot? Constant's going to be pretty easy to spot. So look for big flat spots, right? Okay, so where's the big flat spot? Negative 1 to 1 is a big flat spot? Okay, so constant. Okay, now I need to decide on brackets, right? Okay, so is it flat at negative 1? I didn't know, it's weird, right? It's flat on the right-hand side and it's not flat on the left. Okay, so that right above negative 1, it's flat on the right, and it's not flat on the left. So it's increasing over here, and then it's flat over there. So this one really doesn't have a, it's neither increasing nor decreasing nor constant. It's just kind of a weird spot, right? So I put an open bracket because it's not constant there. Does that make sense? You guys remember the open bracket versus closed bracket thing? Okay. All right, how about the other bracket on 1? Yes, it's got the same problem but backwards, right? So it gets an open bracket. Really, you guys could just remember that increasing, decreasing constants are going to come with open brackets all the time. Right? If it changes, it's going to be one of these weird things where it's 1 on one side, 1 on the other. You can always put open brackets on it. How about, let's see. Whoa, there's lots of more intervals here. Okay, let's do decreasing. Okay, so where is this thing decreasing? Okay, so we're decreasing through here, right? And like someplace in there, right? To there.
Why are we not decreasing on the other side?
This stuff?
Yeah, why is that a decrease?
So as I go from left to right, it goes up, remember? Think about it, if you kind of squint your eyes at it and it was a line, would that line have positive slope or negative slope? Yeah. So it's going up, it's increasing. Cool. All right, so decreasing, I would say those are intervals from 1 to 3 and 4.5 to 6, right? Okay, what kind of brackets do they get?
Close.
They get soft brackets because, right, here at 1, I'm constant on this side and decreasing on that side. That means I'm not decreasing there, right? At 3 here, I'm not constant. I'm decreasing on one side and what on the other? Increasing. So it's not decreasing there. Same thing with these guys. What's the symbol I put in between these? Yeah, I put the U thing, the union, to stick them together. How about increasing? Okay, so my increasing ones are see. So I'm looking at this stuff. Okay, then where else is it going up?
3.
Yeah.
6.
Okay. All right, so I need to write 3 intervals, right? So the first one is minus infinity to -1. The next one is 3 to 4.5, and the next one is 6 to infinity. Okay, and brackets on these?
They're all good.
Yeah, they're all open brackets for the same reason the others are open brackets, except for 2. Yeah, infinity and minus infinity and infinity. What kind of brackets do those get? They get the soft ones because they have to get the soft ones, right? I don't even have to think about those. Those aren't numbers, right?
They're not
Okay.
gonna be close.
You here and here. Cool?
Okay, go back with me on the one, why the soft bracket maybe make.
Okay, so it's a soft bracket. Let me blow up one of these pictures. So let me just pick right here, right? So if I pick right here and I blow it up a bit, what I'm looking at is flat, right? And then going down. So this is the point I'm talking about. Are things constant there? No, because on this side they're constant, but on this side they're not, right? The graph isn't flat at this point because it goes down a little bit on that side. Okay, now is it decreasing? Well, it's decreasing over here, but over here it's flat. Does that make sense?
When do I use the hard bracket?
So when it's supposed to be including, right? None of these cases can be including.
Okay.
Does that make sense? These cases just can't be including because if it switches, then it's got this problem where it's one thing on one side and not that thing on the other side. And if it doesn't switch, then I don't need to write it. Does that make sense? You guys want to see an example where it doesn't switch that's a little bit? Not really. Okay, so an example where it doesn't switch. And this one's only a little bit tricky. So find the intervals where g of x is increasing, decreasing, or constant, right?
I did a poor job with my picture.
You guys see this? This is a graph of a function that we'll talk about this one later. This is g of x is x cubed. Okay?
Does that mean G of X is
Increasing. Sorry, I didn't write the word out. Okay, so I'm looking for increasing, decreasing, or constant, right? Okay, so where is it going up from left to right?
-1, not negative, -1. I'd say 1. I would go over more that one, Between where you were, like right, where it starts going.
Ah, okay. So what you're eyeballing there is a kind of a different thing. You're looking at a rate of change of a rate of change of a rate of change. That's, yeah, way too deep here. Here we're just doing where is it going up, right? So if I move a little bit to the right, does the thing go up? Yeah, it really kind of does everywhere, right? You guys see that? There's this weird spot right in here, right? You guys see that? It's like almost flat there. But it's not actually constant because it's not flat, right? This is a really trippy thing. You really sort of want to write it's increasing from minus infinity to 0. And it's increasing from 0 to infinity. Like, this is what I want to write. Like, in my head, for some reason, I want to say, well, it's increasing over here, and then it's also increasing over there. You see that? Yeah, but this just includes 0, right? So why would I even write all this garbage when I could just write minus infinity to infinity? You guys see that? There's something sort of subtle happening here with that kind of weird locally flat spot. I wouldn't worry about it too much. Okay, so in general, we're just going to do, if it goes up from left to right, it's increasing. So this thing is increasing the whole way.
That's the R, right?
Yeah, so if I wanted to rewrite this, I could write it this way. These are all three the same answer. So pick whichever one is your favorite way of expressing yourself. Cool? All right, I think we need to have some variety of quiz, yeah?
Hold on.
Yeah, don't erase that, please, because I can't see.
So the quiz question is, what point is at the vertex of f of x equals minus 8x squared plus 12x minus 3? And can you tell me whether that point is a maximum or a minimum?